Well, let's take up the next one. Two trains A and B of length 400 meters each are moving on two parallel tracks with a uniform speed of 72 km/h in the same direction, with A ahead of B. The driver of B decides to overtake A and accelerates by 1 meter per second square. Now, if after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? Okay, now let's try and understand the numerical given. It is given that there are two trains A and B which are of equal length. They're traveling with the uniform speed or uniform velocity, which is 72 km/h. So initially the acceleration for train A and train B is 0. They are at a distance apart. Train A is moving ahead of B on a different track, a parallel track. But after 50 seconds, driver of B decides to accelerate by 1 meter per second square. So obviously, you see that B just brushes past the driver of A. So the guard of B just brushes past the driver of A. So you have to calculate the original distance between the guard of B, the guard in the train B, to the driver in train A, even before they accelerate. So let us just see how it looks like if I picturize. So let me call this is train B. So this is guard of B. Okay, this is on a different track. So this is one track on which train B is moving. So this is a parallel track on which train A is moving, right? This is another track. So they are moving on two different parallel tracks. So this is train A. Let's say this is where the driver of A sits. So initially there is a distance between them. I call that as X. We know this is 400 meters in length. Also, this is 400 meters in length, right? So, what's the question? You have to calculate the original distance between them. What do you mean by them? It is the guard of B and driver of A. So this is where the guard of B is, and this is the driver of A. So when you look at the diagram, it is very clear. The distance between the guard of B and the driver of A initially is the length of the train B plus X, which is some separation we have to find out, plus 400 meters, which is the length of train A. So let us write down original distance between the guard of B, which is train B, and the driver of A is equal to how much? 400 plus X plus 400. So 400 plus X plus 400, right? If I call that original distance as S, let us say, so how much is S? It will be equal to 400 plus 400 is 800. This 800 plus X, or it is X plus 800 meter, where X is unknown. Okay, so if we find out X, you can find out the original distance of separation. So I call this as the original distance of separation between them. Just to avoid confusion, I have used a different symbol, which is S. It is actually nothing but the distance, the original distance, which is nothing but X actually. So we know at 50 seconds the acceleration for train A is 0, right? The velocity of train A is 72 km/h. So I convert that to meter per second by multiplying it by 5 by 18. So it is 5 ones are 18 ones are 18 fours are will be 20 meter per second. So let us calculate what is the distance traveled by train A. So the distance traveled for train A is equal to velocity of train A into t plus half into acceleration for train A into t square. So this is nothing but VA is 20, T is 50 plus half into acceleration for A is 0 into 50 square. So this will be 20 into 50 is 1000. This is 0, so this is 1000 meter. So XA has covers a distance of 1000 meters. Similarly, let's calculate XB. So that will be VB T plus half AB T square. Now this is also 20. They are moving with uniform speed. This is 50 plus half into acceleration for B is 1 meter per second square into 50 square. Now 20 into 50 as we know is 1000 plus half into 50 square is 2500. So if you divide this, it will be 1150. So it is 2250 meters. So this is XP. So here the numerical clearly shows. So 1000 is actually 1000 is the distance that is covered by train A as well. So what is the extra distance that train B is covering? It is actually covering an extra distance of 1250 meters due to its acceleration, which is 1 meter per second square. So you get this extra quantity only because of the acceleration of B, whereas since both are traveling with the same speed, they will definitely cover the same distance, but because of the acceleration term you get this extra distance, right? So therefore extra distance traveled by B should be equal to XB minus XA, that is 2250 minus 1000, which is nothing but 1250. Right? So this is actually S, right? Therefore, what is S? S is nothing but X plus 800 so this is when this is the driver of A and the guard of B just brushes past the driver of A, right? So this is how much is X? X is S is 1250. This is equal to X plus 800. In other words, X is simply 1250 minus 800, which is 450 meters. Right? So we know X. Therefore, what is the original distance? Original distance will be 450 plus 800, which is nothing but 1250 meters. So this is the original distance of separation between the guard of B and driver of A. So this is the first method of solving this numerical. This numerical can also be solved by relative velocity. So I'll just show you how to do it in relative velocity. So this is method 2. Now we know the original distance of separation between original distance of separation between driver of A and guard of B is equal to x plus 800 meter, right? So after 50 seconds or at 50 seconds, when I can just write it as a t is equal to 50 seconds, acceleration for B is 1 meter per second square, right? Acceleration for A is 0. Velocity of A is equal to velocity of B is equal to 20 meter per second, right? So now since both the reference frames, which are train A and train B, are in motion, when you write the expression for distance traveled is equal to V into T plus half AT square, V naught into T plus half AT square, which is the general formula. Here, instead of V naught, I can write it as, what is x? X is the original distance. What is the original distance in this case? I write it as x plus 800. Instead of V naught T, I can write it as B is the one which is actually accelerating. So velocity of B with respect to A, because both the reference frames are in motion, into T plus half A into B into T square. So this is another way of solving the numerical. But what is VBA? But velocity of B with respect to A can be written as VB minus VA. Both VB and VA are 20. So 20 minus 20 will be 0. So therefore, this implies x plus 800 is equal to VBA is 0. So that is 0 into T, which is 50, plus half into AB is 1 into 50 whole square. So this will be x plus 800 is equal to 0 plus half into 2500. So this will be x plus 800 is equal to, if you simplify, this will be 1250. So therefore x will be equal to 1250 minus 800, which is nothing but 450 meters. But original distance is given by is equal to how much? X plus 800. So this will be x is 450. So 450 plus 800, we get meter, which you have actually got it here, right? So this is the actual answer. So this is another method of solving the numerical using relative velocity, because both the reference frames are in motion with respect to each other.